हरिः कर्ता।
Now let's look into the final technique to detect outliers, that is Mahalanobis distance method. So Mahalanobis distance is a statistic measure that calculates the distance between a data point and a distribution or a set of data points. It takes into account the covariance and mean of the data points, making it useful for identifying outliers in multivariate dataset. Here we have multivariate dataset. X on X, and one dataset is on x-axis, other dataset is on y-axis, and both were mapped using, we will use the correlation and then covariance and then mean, using all three main parameters, and then we'll calculate the Mahalanobis distance. Okay, so now in simple terms, if you want to put Mahalanobis distance, so Mahalanobis distance measures how far a data point deviates from the mean of a data set. That's it. How far a data point deviates from the mean of a data set, taking into consideration the correlation between variables. It accounts for both the spread, variance, and orientation of the data points. So how many parameters it's considering to find out? No, Mahalanobis distance measures how far a data point, let's take this data point, deviates from the mean of a data set, taking into consideration one, correlation between these two variables, and also variance and also covariance between these two variables. Okay, now let's see how this works. Mahalanobis distance, how it works. Suppose you have a data set with two variables, height and weight, for a group of individuals. So that's what our data set. We have a group of individuals and whose height and weight. For example, soccer players. That's the way. That is the data set we are gonna take. So now you want to identify any potential outliers in this data set. So now how will we do? So the first step that we're going to take up would be, so let me write down here. Let me put this process on writing. So this is Mahalanobis distance method. So data set, that's the player's data set. So this is what the data set we're gonna use. So we have a number of individuals whose height and weights are known. Okay, two variables. So now how do we proceed? So step one is to calculate the mean and covariance of the data set. So compute the mean and covariance matrix, a matrix that describes the spread and orientation of the data points for the height and weight variables in this data set, specifically for height and weight variables. Height and weight variables in this specific data set. Then step 2, compute the Mahalanobis distance for each data point. Mahalanobis distance for each data point. So how do you do that? Using this. So Mahalanobis distance is equal to square root of x minus mean multiplied by inverse of covariance and whole multiplied by x minus mean. So that's what is the Mahalanobis distance. You will have a square. Inside the square, the first one is x minus mean multiplied by inverse, and the whole section would be multiplied with the x minus mean. Okay, this is what is our Mahalanobis distance formula. So this is how we calculate. So in that, x is the data point, mean is the mean of the data set, and covariance, we know the covariance is the covariance matrix. Next, step 3. Step 3, compare the Mahalanobis distance to a threshold. So set a threshold value for the Mahalanobis distance above which data points are considered potential outliers. Data points with Mahalanobis distance greater than threshold are likely to be outliers. Then step 4, identify potential outliers. So data points with Mahalanobis distance greater than threshold are identified as potential outliers in the data set. So now let's take an example. So let's take and weight whatever data that we have mentioned, we'll take that only. Let's take and height and weight as our variables for this example. So let's look into this data. Okay, so we have total 1587 rows. So 1587 individuals or 1587 players heights and weights are available for us. So first what will we do is, let's calculate. So to find out, question is find out or detect the outliers from the soccer players data set. That's what. So as usual, step 1, sorry, step 1, calculate the mean and covariance of the data set. So numpy has been imported, or else let me import one more time. Import numpy as np. I think it will be required, but that's okay. So now height, let me check height. Height is equal to, what's my data? So players and its height in centimeter. Then weight is equal to players weight in kg. That's it. My data set or my variables are ready. Now it's time to calculate the mean of height and weight. So mean height is equal to its mean of, let me directly use a method from mean. So mean of height and mean weight is equal to np dot mean weight. So let me execute and cross check the values. Mean height, oh fantastic, we got the values correct. Mean weight, and that's it. So that's the mean height is 177.45 centimeters and mean weight is 72.65 kg. Now it's time to calculate the covariance matrix of height and weight. Let's do that. Calculate the covariance matrix of height and weight. Just a minute. Weight. So covariance is equal to np dot cov, and inside that I need to put the respective v stack of height and weight. And row variance, row var is equals to true, and then close bracket. So np dot, let me cross check the code, covariance of np dot v stack of height and then weight and then row variance is true. So it's not matching here somewhere. Okay. Now let me cross check the covariance. Yep, see that you got the array of covariance matrix. This is what is our covariance matrix between those respective variables. So now let's get into the step 2. Step 2, compute the Mahalanobis distance for each data point. So let me do that. Now compute the Mahalanobis distance so data is equal to np dot v stack and height, weight, and let me transpose it, and let me cross check the value here. It's data. Yes, that's it. It's done. Now mean is equal to np dot array mean height comma mean weight, and let's add one more, that's inverse covariance is equal to np dot lin alg. From that linear algorithm, from that I am going to check inverse and then covariance. That's it. Let's cross check the inverse covariance. That's it. This is what we got the inverse of every covariance from the covariance matrix. So now it's time to calculate the Mahalanobis distance. Mahalanobis underscore distance is equal to np dot square root of np dot sum of everything. I'm using for the numpy only, just to make things simple. Np dot of data minus mean, then I have inverse covariance, then I have to multiply everything. I just want to see the formula here. Yeah, inverse covariance and multiply all stuff with the x minus mean. Okay. So data minus mean, and so inverse covariance, and multiply this with data minus mean, and then axis is equals to 1, and that's it. That's our let me cross check the distance, how much Mahalanobis distance we got. Yes, that's it, you got the Mahalanobis distances here. So now it's time to compare the Mahalanobis distance to a threshold. Step 3, compare the Mahalanobis distance to a threshold. So let's set a threshold for Mahalanobis distance. So threshold is equal to 3 this time, and then let's identify potential outliers. So simple, outliers all done, it's very easy now, is equals to data of Mahalanobis distance which is greater than threshold, and that's it. And finally let me print potential outliers. Print potential outliers, and then print outliers. So what's the issue? It's print. Okay, that's it. You got your outliers, and these are the potential outliers, keeping centimeter and weight, centimeter weight, centimeter kg, centimeter kg, keeping both things in mind. These are the candidates which are the potential outliers of my soccer data. Maybe they are having too much of height and then too much of weight too, so that's the reason they were kept out. So these are the potential outliers from my soccer data or soccer players data, and this is how we use or leverage the Mahalanobis distance method to detect the outliers from data set from the multiple variables, multiple continuous variables